We want to solve this equation, but keep in mind, it doesn't say on an interval 0 to 2 pi. So if you're not on a specific interval, there is an infinite number of answers. Because, you know, if something's true at, say, 30 degrees, it's true at 360 plus 30, because we'd be back to the same spot, plus another 360, or minus a 360. So there's an infinite number of answers. And one of the biggest keys in solving these is, when do duplicate answers happen? Well, on a trig function sine and cosine, secant and cosecant, everything repeats every 2 pi. We've talked about the period of something is how much space it takes before it repeats the pattern. So keep in the back of your mind that every answer will repeat every 2 pi. Okay, so then, following our main strategy, get the trig function by itself. I want to subtract the square root of 2 over, then I want to divide by 2, and so I end up with the sine of theta equals this fraction. The meaning of that is that we're looking for the angle measures where, because cosine comma sine, the y coordinates are the sine of theta, so we're looking on our unit circle for where does the y coordinate equal negative root 2 over 2. Okay, so looking around on our unit circle, we find that we have y coordinates of negative root 2 over 2 here and here, which happen to be at 5 pi over 4 and 7 pi over 4. So yes, our answer in general are those two right there, but because we're not on a set interval, if I have graph the angle 5 pi over 4 and then go an extra full circle, in other words, an extra 2 pi, I want to go 2 pi, 4 pi, 6 pi, or rotate backwards 2 pi. So the way we can write that, the notation that we want to use, is you say plus 2 pi, but I've thrown this k in here. And the k, this is just a notation for an integer. K is an element of the integers. And remember, integers are like 0, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3. So if I go 2 times 0 times pi, I get back to this. If I go 2 times 1 times pi, I've added 1 circle. If I put in 2, I've added 2 circles, 2 revolutions. If I put in negative 1, I've subtracted out a revolution. So that's what that notation is doing, is getting you to all the repeats. Similarly here, I'm going to say or, because I also want repeats of this one. So I just do the same thing and say plus 2k by, such that k is an element of the integers. I am going to do one more example, but before I do that, I just want to really emphasize what that notation just found. So if I let k equals negative 2 in that first one, I end up with negative 11 pi over 4. If I put in negative 2 in this one, notice I'm getting different answers. And I do the same thing, and I'm just going to quickly put them up here because the general idea is all we care about here. All these yellow ones are correct answers. And a fallback plan, if you turned each one of these into decimals, you could go to Desmos or use your graphing calculator, and you could graph the sine of x, like y equals sine of x, and then graph y equals negative root 2 over 2, and where those intersect are going to be the decimal versions of all of those. So if your life depended on it, you're like, did I get the right answer? That would be a way that you could feel really confident that you had the right answer. Something else that we're not going to have to do right now, but just I really want to make sure we table this general idea, is if I start listing those from least to greatest, I have no repeats. So I need both of these equations. But sometimes what happens is that one of the equations generates all of the other ones, so it's redundant to write both. Okay, so just one more example of the same thing. I'm going to get the cosine by itself by adding 1, dividing by 2. The meaning of this is what angles have cosine comma sine an x coordinate of 1/2. I go to my unit circle, and in these two locations, these points have x coordinates of 1/2, and the angle measures where those are located are pi over 6 and 5 pi over 6. So those are, in general here, my answers. But to list out all the extra ones, I'm going to put on the notation plus 2 pi k, such that k is an element of the integers, and plus 2k pi, k is an element of the integers. And these are going to, if I were to let k be -1, 1, 0, 2, 3, 4, they're generating different angle measures, so I need them both. Sometimes in textbooks they force you to write your own equation that generates all of them instead of writing it as two separate equations, but you're fine just to put both of them.